Hello, welcome to lesson 21. In this lesson, we are going to look at deviation produced by small angle prism, grazing property of light rays as applied to prisms, and then limiting angle of the prism. Let us begin by looking at the deviation produced by small angle prisms. So we are going to consider a ray of light through a small angle prism, and so we shall have this. So we know that for small angles, when we talk of small angle prisms, it means that this A is a small angle, and I1 and IR1 are also small angles measured in radians. Applying Snell's law at M, we shall have Ng sine I1 is equal to we shall have Na sine I1 is equal to Ng sine R1, but we know that Na is 1, which will give us sine of I1 is equal to N sine of R1, where N is the refractive index of this glass. And then we shall also remember that this I1 and R1 are small angles in radians, and so sine I1 is approximately equal to I1, and sine R1 is approximately equal to R1. When we replace that here, this will be I1, and then this will be R1. So we shall have I1 is equal to N R1. From the diagram, R1 plus R2 is equal to A, and so R2 is going to be A minus R1. And then we also need to note that since R1 and A are small angles in radians, it implies that even R2 is also going to be a small angle because of the relation R is equal to A minus R1. And that implies that we can apply the same condition when we have R2 and I2. So we shall also say that sine of R2 is approximately equal to R2, and sine of R1 is approximately equal to, and sine of I2 is also approximately equal to I2. So that condition also will apply here, the same condition we applied here. And so when we apply Snell's law here, we shall have our sine of N sine of R2 is equal to sine of I2, and therefore I2 is equal to N R2. So the deviation is going to be D, which is D1 plus D2, and then we know that D1 is the I1 minus R1, and then D2 is I2 minus R2, and then we shall get that. Then replace for I1 and I2. Here we have I1 from here, from equation 1, then from equation 2 we have I2, which we shall replace here, and we shall have this. Then we shall factorize out. First of all, collect the like terms. This, where bring this, where there's a, okay, we shall, when we look at this is N R1, so when we first of all factorize out R1, we shall have N minus 1, and when we also factorize here R2, we shall have N minus 1. So at the end of the day, we shall get our D as N minus 1 into brackets R1 plus R2. Then we know that R1 plus R2 is equal to A, and so D is going to be N minus 1 times A. And that is going to be the deviations produced by small angle prisms. Let us also look at the grazing property of light rays as applied to prisms. So we need to know that if a ray of light is either such that the incident angle or the emergent angle is equal to the normal, then the ray is said to graze the refracting surface of the prism. So what we are saying is that so if we consider this ray of light incident at an angle I on a glass prism of refracting angle is situated in air, with the emergent light grazing the other refracting surface of the prism as shown in this diagram we call the maximum deviation diagram, we shall have this whereby the second surface is being grazed, and therefore this is going to be 90 degrees to the normal. And so we know that R1, so the R plus C is going to be A, since this C is a critical angle. We have this refraction being 90, so angle of refraction is 90, so this is C. So we shall have R plus C is equal to A, and therefore R is going to be A minus C. And then we are going to apply Snell's law at M. When you apply Snell's law at M, we shall have N A sine I is equal to N G sine R, and therefore we shall have that. And then when we substitute for R in that equation, remember R is A minus C, and so we shall have sine I is equal to N G sine of A minus C. Refractive index of air is 1, so that's why this is having a coefficient of 1 there. And then when we expand this according to trig, we shall have sine I is equal to N G sine of A cos of A, so the sine cos of C minus sine of C cos of A. That's according to trig when we expand this trigonometry. So we form this other equation. Then we shall also apply Snell's law at N, and then we shall have N G sine of C, N air sine of 90, but N air is 1, and then sine of 90 is 1, so we shall have our sine C as 1 divided by N G. That will form this other equation. Then also we know that, but we also know that from trig, if I have cos squared C plus sine squared C is equal to 1, and so cos squared C is equal to 1 minus sine squared C minus sine squared C minus sine squared C. This is 2 squared. So we shall have that, which implies that if I want to get cos, I'll have cos C is going to be the square root of 1 minus sine squared C. And so we shall have this. So where we have sine squared C, we shall substitute with 1 over G squared. And so we shall have this. And then when we get the LCM, we shall have N squared being equal to Ng squared being equal to Ng squared minus 1. And then when we get the square root, we shall have the square root of Ng squared minus 1 over Ng. So cos will be giving us that. Then after that, we are going to substitute for C, sine of C and cos of C. We are going to substitute in that equation C. Where there is cos C, we shall substitute this, and where there is sine C, we shall substitute this, and then we shall get this. Then after getting that, we want to make Ng squared minus 1 the subject, so we shall make this the subject, and then we shall have, when you try to simplify and make Ng squared minus 1 into square root the subject, we shall have this, and then you square both sides, and then make Ng the subject. We shall have, after squaring on both sides, we shall make Ng the subject, and then we shall have Ng is equal to 1 minus, so the 1 plus the square root. We shall have Ng as the square root of 1 plus, open brackets, sine of I plus cos of A divided by A squared. That's by simplifying this. When you square this side and square this side, we shall have Ng squared this side, and then this 1 will go the other side, and then you get the square root and remain with Ng into square root of this one. Remember, I had squared this, so we shall have this. Let's look at some examples. 1. Monochromatic light is incident at an angle of 45 degrees on a glass prism of refracting angle 70 degrees in air. The emergent light grazes the other refracting surface of the prism. Find the refractive index of the glass material. So let us have this illustration of what we are talking about. So we are seeing that it is grazing the second surface, so this angle is 90. So since this is 90, this is going to be C. since we have the refractive index of A as 1, and then we don't have the refractive index of glass. So we shall apply, we can apply Snell's law at P and then get that, But first of all, we need to note that this R can be got by getting 70 minus C. So what we need is to first apply Snell's law at Q so that we get C, and then after that, but anyway, we don't have the refractive index of the glass, so that means that since we don't have the refractive index of glass, we shall begin by working from this other side, from P. So we shall apply Snell's law at P, and then we shall have N air sine 45 is equal to N glass sine R. This is 1, so, and this is going to be, R is going to be 70 minus C. So we shall work from first principles, and then we shall have our NG, we shall have NA as 1, and then we shall have our sine of 45 being equal to NG sine of 70 minus C, because we are replacing for this in this equation here. So we shall have sine of 45 equal to NG sine of 70 minus C, and then after that we are going to expand this in the same way we did, and then when we expand this, we shall be able to get sine of 70 degrees cos of C, and then minus sine of C cos of 70 degrees. But also, let us apply Snell's law at Q. When we apply Snell's law at Q, we shall have NG sine of C is equal to N air sine of 90 degrees. But we make NG the subject, and so we shall have NG is equal to 1 over sine C. Remember, A is 1, sine of 90 is 1. So if I make NG the subject, shall have 1 over sine of C. Then we are going to replace this equation D, that is replaced for D, that is N equal to 1 over sine C. We are going to replace that in equation C. For where we have NG, we shall have 1 over sine C, and that will give us sine of 45 is equal to sine of 70 minus C divided by C, divided by sine of C. When we expand that, we shall have this sine of 45 degrees sine of C is equal to sine of 70 degrees cos of C, sine of C cos of 70 degrees. So that's what we shall have. Cross multiply this and then expand this according to trigonometry. We shall get this. And then when we simplify by bringing sine of C this other side, we shall have, and making sine C and factorizing out sine C, we shall have sine of 45 degrees plus cos of 70 degrees, which will give us sine of 70 degrees cos of C. So we shall be having that. Then we shall divide it through by cos of C. Dividing through by cos of C, we shall have tan here, and then this will be 1, and then we divide by sine of 45 degrees plus cos of 70 degrees. Then we shall remain with tan of C as a sine of 70 degrees divided by sine of 45 degrees plus cos of 70 degrees. And then we shall get the sine arc, so the tan arc of this, which will give us C as 41.9 degrees. But remember, from equation D, we have NG is equal to 1 over sine C. So if we replace for C, we shall have NG as 1.497. That's going to be the refractive index of the glass material. Then number 2, a ray of monochromatic light. So a ray of light is incident on one refracting face of a prism of refractive index 1.5 and refracting angle 60 degrees. Calculate the minimum angle of incidence for the ray to emerge through the second refracting face. So we are applying the minimum angle is what we want. So if it is a minimum angle, then the ray must be grazing the second interface in order for us to have the minimum angle of incidence. The ray must be grazing the second interface. So we shall have this. And so here we have the refractive index of glass this time round, and have the refractive index of air, which is 1, and this is 90. So we can get C by applying Snell's law at Q. Let's apply Snell's law at Q, and then we shall have N G sine of C is equal to N air sine of 90, which will give us 1.5 sine of C is equal to N air sine of 90. This is 1 and this is 1, which will give us our C as 41.8 degrees. Then after doing that, we shall get R1 by subtracting 60 minus C, which is going to give us 60 minus 41.8, and that will be 18.2 degrees as R. Then we shall apply Snell's law at P. When we apply Snell's law at P, we shall have N air. Okay, if we move from glass, N glass sine R1 is equal to N air sine I mean. And then we shall make sine I the subject. This is 1, and sine I mean the subject, and this is 1. So we shall multiply this and then get the sine arc of this value here, which will give us I mean as 27.9 degrees. But remember, we can also use the formula, since we know that this condition we derived when this is grazing, and we had N-G being 1, square root of 1 into brackets sine of I plus cos of A divided by sine of A squared. So if we substitute, this is 1.51 here, then this is going to be sine of I mean, and then cos of 60, and then divided by sine of 60. So we shall have this, and then when we square on both sides, we shall have 2.25 this side, and then take this one this side, and then again get the square root this side and this side, then this square will get off, and then we shall multiply by sine of 60 and then subtract 60, remain with sine of I mean, and then get the sine arc of that answer we would have got, which will give us I mean as 27.9 degrees. Let's look at the limiting angle of the prism. The limiting angle is the maximum refracting angle of the prism for which the emergent ray grazes the second refracting face. And so we shall suppose that the incident ray grazes the first refracting surface, then the limiting angle A is going to be given by A is equal to 2C, where C is the critical angle of the glass-air interface as shown in this illustration. So if we let this also be grazing the first face, then this is 90, so this is C, and if it is grazing this side, this is 90 and this is C, the critical angle, and therefore C plus C is equal to A, and therefore A is going to be 2C. Yeah, thank you for your attention. We meet in the next lesson.